Let's go over more power systems. In particular, we're going to talk about load sharing. So load sharing is where you've got two or more power sources in parallel on the same bus bar supplying a common load. And this can be as simple as 2 generators in parallel to each other, or it could be 4 generators, a bus tie and a main supply, all the way up to maybe 8 generators, 4 solar inverters, a wind turbine, a hydro turbine. What the last thing you want to happen is that hydro turbine turning those 4 generators into a motor. Active power, kilowatts, is determined by the governor of the power source. So on a generator, this is the generator's speed governor. When you're in parallel, the governor no longer regulates speed, it now regulates kilowatts. So to get on topic of what this question was actually talking about in the example that I gave, the way to reduce the load on the generators, which therefore increases the load on the mains, is to pull back on the fuel. So the generator is electrically locked to the mains, the frequency is locked, you can't slow down the generator. But by reducing the fuel, you're reducing active kilowatt output of that generator. In the example I gave in that video, the load was 1,200 amps. So by reducing the amount of fuel that those generators got, they were electrically locked to the mains still, so we reduced the kilowatt output of the generators, but the mains picked up the slack. So a quick summary then, less fuel, less kilowatt output on the generators. The mains is still locked in with the generators, so therefore picks up the slack because the load still needs the same amount of current. I could talk about this forever and a day, but let's leave it there. Let me know what you think down in the comments below.